Now see here, decay rate or activity. Actually we have done the number of atoms disintegrating per second. So calculating the number of atoms disintegrating per second or the number of atoms disintegrating is not so easy to measure. But if you measure the decay rate, that means R, that is represented by R, that is also called activity. It is a positive quantity, that is minus dN upon dt. So this is easily measurable. So in place of the number of atoms disintegrating, we use here decay rate or the activity. So we have got this value n is equal to n naught e raised to power minus lambda t. If we differentiate it, we will be getting R is equal to R naught e raised to power minus lambda t. Here R naught can be taken here lambda n naught. Actually when we differentiate it with the time, we can get all these, and this R naught is lambda n naught. This is the decay rate at time t is equal to 0. So this is about the decay rate. So we can calculate decay rate and we will be getting question based on decay rate. Now another part, we can also do one more concept related to this radioactivity, that is called average life. Average life, or we can say that is here mean life. See, average life or mean life of the radioactive element or the radioactive material is equal to total lifetime of all the atoms, that is tau is equal to total lifetime of all atoms divided by total number of atoms present in sample So initially we can write here initially. So when we solve it and we can get this is tau is equal to 1 upon lambda. So this formula is important for us. So average life or the mean life of the radioactive element is equal to 1 upon lambda. And you know the unit of this also we can do. The SI unit of rate of activity or the decay rate, that is called here, we can write here becquerel. One becquerel is equal to 1 decay per second. So this is the SI unit of the rate of activity, the rate of the decay, and also we can say the activity.